On periodic tables that atomic masses of different elements are listed, atomic mass is simply the total number of protons and neutrons in an atom. Strangely, the atomic masses of different elements are not listed as whole numbers. Some are not even close. So what is going on? Can you have a fraction of a proton or neutron? No, you cannot. While they aren't exactly fundamental particles, they are made of quarks. It takes extremely high energy situations to separate them. Something else is going on here. The answer is a concept known as isotopes. An element is defined as the number of protons in an atom, hence the whole number values of atomic number. But there is no rule stating an exact number of neutrons every element has to have. Actually, there is a bit of a rule. Neutrons are required to hold atoms together. You can't just slap 100 protons together and expect them to stick because protons are positive, so they repel each other. Also, you can't have too many neutrons because if there are extra neutrons that are not required to hold an atom together, they would rather become a slightly lighter proton and release a bit of energy. To tell what isotope an atom is, there is a naming system, whatever element it is, and the total number of protons and neutrons in its nucleus. For example, carbon-12. In any element, there are many different isotopes occurring in different fractions in nature. Using the example of carbon again, it is 98.9% carbon-12, 1.1% carbon-13, and 1 part per thousand carbon-14. This is the reason why atomic masses on the periodic table are listed with decimal digits. The different isotopes' atomic masses are averaged together based on their occurrence in nature. Therefore, their values will naturally lose their integer property. An important distinction in isotopes is stable isotopes versus radioisotopes. Stable isotopes are stable, while radioisotopes are radioactive. This radioactivity makes them decay over time, which makes them less common. The shorter an isotope's half-life, the less common it will be. As we climb higher and higher up the periodic table, the less and less stable isotopes each element has. Once we pass lead, there are no more elements with stable isotopes. Some are very close to stable, like bismuth-209 with a half-life of 19 quintillion years, but not actually stable. Overall, isotopes are versions of the same element that are heavier or lighter due to how many neutrons they have. They can have slightly different properties and occur in different commonalities. They can also be radioactive, which is why there are no stable elements past lead.